Today we will discuss the structural hazard. Structural hazard occurs when two instructions access the same hardware at the same time. So, for example, let's say we have a set of instruction in which two instruction access the same hardware, that is memory, at same clock cycle. Okay, let's say for example, one instruction is accessing the memory for the data, and the another instruction is accessing the memory for the instruction. So in that case, the hazard will create, and that hazard is called structural hazard. Okay. So what is the solution for this structural hazard? First solution is the to delay the second access by one clock cycle. Another solution is the Harvard architecture. That means provide the separate memory for the data and the instruction. So that's why we can. So that's why we can access the memory at the same time. Now, hazard will not create because we are accessing the data from the data memory. We are accessing from the instruction from the instruction memory. Okay. So now we'll see the examples how the hazards are created. Now I will show you the through the examples how we can remove the hazards. Okay, let's say these five instructions are there. Okay, LWR1, comma 10 within bracket R2, add, subtract, multiply, division. These five instructions are there. Now I will draw the time phase diagram for this set. So at first clock cycle, first instruction goes to instruction fetch. Second clock cycle, the first instruction will go to decode. At the same time, the second instruction will enter into the instruction fetch. At third clock cycle, it will go to execute. The second instruction will go to decode. Third instruction will go to the fetch. Okay. Now, at fourth clock cycle, first instruction enters into the memory. Second instruction goes to the execute. Third instruction goes to the decode. And fourth instruction goes to the fetch. Now see. So here structural hazard is created. How? So here in the first instruction we are accessing memory. Okay. For what? To read what is present in this memory location. Okay. Now, for the fourth instruction, we are accessing the instruction from the memory in the instruction page. So we cannot overlap the memory and instruction page at the same clock cycle because this here we are reading the memory, and for data. Okay. And here we are reading memory for instruction. Okay, so that's why we cannot do instruction fetch here. So what we will do? We will just delay the second access. That means at fifth clock cycle it goes to write back. So I cannot do here. Okay, it will at this will goes to the memory. Third instruction will go to the execute. Now instruction fetch. Now I will do here. Okay. So what I can write here? What I will write? So here I will write stop. Instead of instruction fetch, what I will write? I will write stop because I cannot do instruction fetch. I cannot do instruction fetch. So what is stall? Stall is a pipeline bubble in which flows through the pipeline. Okay, taking space but carrying no useful work. Just we are taking the space. Okay, so this is what the solution of the structural hazard. So that means at this cycle we cannot do the instruction fetch, just delay the second access by one clock cycle. Now at sixth clock cycle, what will happen? Now the first instruction is completed. First instruction is completed, write back. Second instruction will go to write back. Sorry. Okay. So can you tell me now here memory and instruction phase is overlapping? Will it create the structural hazard? No. Why no? Because structural hazard is occurred where the one instruction is requiring the memory for the data, another instruction is requiring for the instruction. So in this case, in this fourth clock cycle, you see the first instruction is accessing the memory because it is a load instruction. It is a load instruction. Okay. And at the same time, multiply instruction requires the memory to fetch the instruction at the fourth clock cycle. So that's why you cannot do overlap. Now comes the fifth clock cycle. Fifth clock cycle, second instruction is at memory stage, but it doesn't access memory. Doesn't access memory. Got it? See, this memory, it will pass to the memory stage, but it doesn't access the memory. Okay, so that's why the multiply instruction can fetch the instruction. Okay, so we can overlap here, but we cannot overlap here. Understand the point? Now, at sixth clock cycle, this will go to write back, this will go to memory, this will go to ID. Now, this division will go for the IDF. Okay, 7. Write back. Just complete the time phase diagram. Execute ID. 8. Memory. Execute 9. Write back. Memory. 10. Write back. Okay. So this is the example how we are removing the structural hazard. Just see the points. Another ones. See, the structural hazard occurs when one instruction is load or store. First point. If the instruction is load or store, there may be the case structural hazard may occur. If there is no load and store, then there will be no structural hazard in the pipeline. If there is a load and store instructions there, then we will check whether a structural hazard is there or not. If it is there, then just delay the second access. Okay. So if you will see at fourth clock cycle, first instruction goes to the memory. At the same time, this fourth instruction, that is multiply, goes to the instruction page. So at the same time, we are accessing the memory, so we cannot do it. Just make the stall here, and in the next cycle, we can do the instruction page. Now, question is here is also memory is overlapping, but second instruction is not a load or store. It is a add instruction. So add instruction is not accessing the memory for the data. Okay. So that's why memory and IF we can do overlap at the same clock cycle. So this is your structural hazard.